When I was creating my video about the rule of three, I was searching the internet and found a text problem called the potato paradox. It's a text problem that is infamous for its tricky and misunderstandable formulation. I already knew it from earlier and was kind of surprised that it has an own wiki page. It's even a pretty long wiki page. Well, the potato paradox seems to confuse a lot of people, so let's take a look at it. It states, you have 100 pounds of potatoes, which consist of 99% water. You then leave them outside and they dehydrate a little. Now they consist of 98% water. And the question now is, what is their new weight? So, first of all, I will show you the wrong solution. If you are not carefully reading the problem, you could end up in this solution here. So 1% of the original weight gets lost because of dehydration. 1% of the original weight is 1% of 100 pounds, which is 1 pound. Now you calculate the new weight by subtracting 1 from 100. So 100 minus 1 means 1 pound is lost because of dehydration, which is 99 pounds. And you can write this as 98 plus 1 pound, where 98 are the 98% water of the 100 pounds, and the 100 pounds are the original weight, so 98% water of the original weight plus 1 pound dry weight. And as I told you before, this solution is wrong. Why? Because we are wrongly assuming that the 98% and therefore the 1% refer to the original weight of 100 pounds. But this is not true. The 98% do not refer to the original weight of 100 pounds. When reading the problem carefully, we find out that the 98% refers to something else than the original weight. It says, now they consist of 98% water, which means after the dehydration process they consist of 98% water. So after the dehydration process they consist of 98% water. So the 98% do not refer to the original weight, but to the new weight after the dehydration process. So one more time, the 98% water do not refer to the initial weight of 100 pounds, but to the new weight after the dehydration process. Let's visualize the problem and the solution in a picture so you understand what is happening. So first of all, you have 100 pounds of potatoes. These potatoes get dehydrated and lose water. In the end, they weigh something else because of the dehydration. Let's call the new weight X. Now we will take a look at the percent numbers. So in the beginning we have 99% water, which means 0.99 times 100 is 99 pounds. So in the beginning we have 99 pounds of water. And we also have 1% dry weight, which means 0.01 times 100 is 1 pound. So 1 pound dry weight. After the dehydration process, 98% of the new weight X, which you can also see here, consist of water, and 2% of the new weight X consist of dry weight. And as I told you before, these percent numbers here, 98% and 2%, do not refer to the initial weight, but to the new weight x. So these percent numbers here, 98% and 2%, refer to the new weight x, which you can also see here. You can also see in this picture here that the dehydration process only changes the water amount of the potatoes. So only water gets lost. That's why it's called dehydration, which means dehydration only has an effect on the water part. The dry weight is unchanged by dehydration. So the dry weight, this here and that here, is not affected by dehydration. Dehydration only affects the water part of the potatoes. Or in other words, the weight of the dry material is the same before and after the dehydration, because dehydration doesn't have an effect on this weight, on the dry weight. Which means this number here, which describes the weight of the dry material before the dehydration, has to be the same as this number here, which describes the weight of the dry material after the dehydration. So once again, the dry weight has to be the same before and after the dehydration. So we get this formula here. So 0.02 times x, which is this number here, has to be equal 1, which is that number here. By rewriting this, we can solve for x. So x is 1 divided by 0.02, and by calculating this number here, we get 50 pounds. And this here is the true solution. So the new mass, or the new weight of the potatoes, is 50 pounds. And this is the true solution. So you see, it's not that difficult at all to solve this problem and find the new weight x. The paradox lies in the formulation of the problem and also a little bit in our expectations. It's important to understand that the number 98% does not refer to the initial weight of 100 pounds, but to the new weight x after the dehydration. By the way, if you don't like potatoes, you could also formulate this problem by using pickles or melons, because they both contain a lot of water. Okay, if my video helped you understanding the potato paradox, please consider liking this video and subscribing to my channel. Thank you for watching my video.